Hello everyone, my name is Mahdi. I'm very happy to be here today. I want to get started.
Modern Data 101 presents the Modern Data Masterclass.
Hello everyone, my name is Mahdi. I'm very happy to be here today. I want to get started first of all by thanking the Modern Data Company team for the invite. I think this is a really cool initiative. I also want to thank you for tuning in to the session. Today, the title of the session is Data Modeling for Data Products. I know it may sound a little vague and potentially cliche, but don't worry, we're going to do a lot of practical tips. We're going to discuss quite a few interesting topics, and we'll also go through a bit of theory and basically everything around data modeling for a data product-oriented world. To get started, I want to first introduce myself. So my name is Mahdi Karabiben. I have been working in the data space for more than 8 years now. I switched between different hats in that time, from the engineering side of things to the product side where I'm currently working. So today I'm senior product manager at Cfly. It's a data observability company. Before that, I was staff data engineer at Zendesk, working on the company's data platform. And before Zendesk, I switched between different industries and different types of companies. I worked in finance at FactSet and Crédit Agricole, and also in the ad tech space at Numbly. So as you can see, I navigated different industries, different types of companies, also worked with different types of data, all within the context of building petabyte scale data platforms. And so the constant thing between all of these experiences was the scale of the data and trying to build platforms and tools that allow to handle data at a very large scale. So to go through like the key areas that we're going to focus on today, I'm going to start by a bit of context just to ensure that we're all on the same page to go through the definitions of the key topics that we'll discuss and also the reasoning behind why this topic matters today. Then we'll go through the practices or like the practices that allow us to adapt our data modeling and how you model your data to the data product-oriented environment in which most of us are currently operating. The next section will be going through the practical side of things to discuss tools, frameworks, and what are the different components or things that you should have in your toolbox as you tackle building a data model for a data product-oriented environment. Finally, we'll end with a conclusion where we'll cover like the key learnings and the key things to keep in mind as you move forward and as you go back to your own data environment and you adapt your data modeling for data products, if that's something that you're currently working on. All right, and so to get started, let's go through the context. What I want to do here is to ensure that we're all aligned on the two key definitions of data modeling and data products. If you're a data engineer or if you have been working in the data space, these are probably two very familiar concepts to you, and you really don't need to have them redefined to you yet another time. But the idea is to ensure that we're sharing the same definition here. For data modeling, it's a little more straightforward. So it's the process by which you define and structure the relationships and constraints of your data. You can do it using different methodologies in the data space. We're mostly familiar with things like dimensional data modeling or data vault. And you can also do it at different levels, starting from a conceptual, very high-level data model to a physical data model that tackles the constraints and the technical characteristics of your data platform. For data products, it's a little more ambiguous and it's a little more controversial. There are different definitions in the space. I think if you ask 10 data engineers about what's a data product, you would probably get 9 different answers. There's one definition that I've enjoyed quite a bit that's currently slowly becoming the standard. I adapted a little here, and it's basically thinking of a data product as a reusable, active, and standardized data asset that's designed to deliver measurable value by applying product thinking principles. And I think the second part of the phrase is the most important one, which you introduce the notion of something that's measurable or measurable value and the notion of applying product thinking principles to a data asset. This asset it can contain different artifacts or different data entities. It's enriched with metadata like governance policies, data contracts. You can imagine things like documentation, for example, and so on. And usually when you think of a data product, it's aligned to a specific data domain or specific use case. So these are the two key definitions that we're going to keep in mind as we continue with the session. In terms of thinking about data modeling for data products, I want to very briefly walk through the timeline of how we get here, or how do we today say that data products are critical for how we build data platforms. So the starting point is like 50 years ago, we had a lot of siloed systems that contained data. It was difficult and even impossible like to build analytical processes on top of them or to centralize the data in one place. Then we had a big era of data warehouses. So here I'm talking about the 90s, where you had a lot of practices, a lot of standards, a lot of tooling around data warehouses. It was the era in which like dimensional data modeling became a thing. And it became the standard in terms of how you want to model data for analytics. At that time, the process was very long. It was done via waterfall process. So you would do quite a few steps, taking from weeks to months until reach a point where you have a data model, which then becomes very rigid. It's costly to update. It's costly like to switch based on like how the business change. And it was also deeply connected to the constraints of the platform itself. Like the technical constraints that we had in the 90s are very different from the constraints that we have today in our data platforms. Then there is like the whole Hadoop era. The main thing that changed is now we have more resources. We fixed quite a bit of challenges around scalability, around doing things in distributed manner. So we had distributed storage, distributed compute, and the question became about storing as much data as possible and processing as much data as possible, and also opening the door to processing and storing unstructured data or data that's not like stored in a relational database. This whole era like was also a big move away from data modeling and very rigid processes we had in the 90s and in the 2000s. It was more about doing more of the data and without like setting the governance or trying to think of how can we do more while we maintain the best practices of like the last 2 decades or more. After the Hadoop era, we had a few years in which the modern data stack was all the rage. What changed here is that we simplified a lot of the technical hurdles of the Hadoop ecosystem. So instead of like components that were deployed on-premise and that required a lot of maintenance, we had cloud-based platforms, and a lot of the Hadoop ecosystem components became SaaS tools that you could subscribe to and activate with the click of a button. The data warehouse itself became cloud-based, it became serverless, distributed, scalable, and a lot of the complexity was abstracted from the data teams. On the other hand, that also means that things started to move a little too fast. Data modeling was still something that not all data teams did. It was still in the background. It's still not a practice that's like democratized within the data space. That meant teams built ad hoc pipelines, tables weren't governed, processes weren't governed, and that ended with very bad or like terrible data quality, data that's difficult to maintain, data that's not governed, and data that in the end wasn't so much useful. In the last, let's say maybe 5 to 6 years or even less, we started to have a transition towards processes that focus on the value that we get out of the data. And the keyword is really value. By doing that, a lot of the like modern data stack approaches were like switched to a framework in which we have more ownership. The ownership is getting more decentralized. So it's not the data team who owns everything, but the teams that produce the data get to own the data they generate. And we started to talk about data contracts and ensuring that the data that's being produced meets certain standards. On the other side of things, in terms of like how the data is consumed, we also started to focus on what's the value we're getting from the data, what are the use cases we're serving, what are like the main business needs that are getting served with the data. And that means that as we go back to focusing on the value, focusing on building scalable and data pipelines that we can maintain, there was a big push towards going back to the data modeling approaches of the 90s and the early 2000s, in the sense of doing things in a governed manner, designing the data model, ensuring that things make sense in terms of the cost, in terms of how we design pipelines, in terms of how we make the data available for querying, and in terms of scalability, both like in the number of assets and the number of queries that we run on top of these assets. And so that brings us to like the key topic of the discussion. How do we adapt the data modeling approaches that we're all familiar with to a certain extent to this data product driven era? There are a few questions here that we're going to try to answer. First one, like, what's the role of classical data modeling approaches and methodologies in this era? When we go back to dimensional data modeling or data vault, is it something that still makes sense? How can we adopt the data modeling that we've been doing throughout the past years, even during the modern data stack days, to a use case driven and a user centric process? How can we model for a decentralized data landscape in which different teams own different parts of a data model, in which the data is no longer like owned mainly by the data team or like a central data team, but instead you may have different satellite teams or different entities that own different parts of a model? And finally, how do we do all that while maintaining the optimization of performance, cost, and also agility throughout the process? These are the four questions for me that are top of mind and that will greatly influence how we do data modeling in a data product driven world or data product driven company. And the aim of the session is to tackle them in two times. First one with the processes, and the second part will focus on the tools and frameworks. All right, so now let's get started with the data modeling practices that are adapted for a data product oriented world. To get started, I want to tackle a concept that's very basic and very foundational, at the same time very tricky to get right, and that may become complex and delicate in different scenarios, which is starting with why and understanding the business use cases and the business needs for the data. This is something that highly depends on your business. It highly depends on like the stakeholders you work with, and it's specific to your use case. That's why it usually gets delicate, and it's really important. It's really critical exercise that you have to start with. The idea here is to ask all the questions you can think about to understand why the data matters and which data matters. So you can think of like the key business areas in which data can be leveraged. You can think of the current use cases, the current problems, the current questions that certain organizations or certain personas within the companies don't have answers for. The only right way to do this is to ask questions and to do it at scale. You can think of surveys, you can think of Slack messages, you can think of Zoom calls. The idea is to get with as many people as possible who interact with the data and try to understand their problems, the current blocking points, and the potential use cases for the data at the company. The second set of questions you need to think about is the main business needs at the data domain level. So once you start thinking at a high level, you will see that there are few alignments for the data, few categories in which you can put the data, which are the domains. Once you define the domains, or once you have alignment in terms of like the domains you want to work on, you need to align with the business on the needs for every domain and the key areas every domain would be helpful for the business in the short term, especially. Once you're at that point, you want to look into metrics and you want to say, okay, what are the key metrics that matter for the data? What are the key measures and calculations that the different stakeholders and different personas mention when they talk about the data? In the tools section, we'll go through a very practical framework that you can leverage to define metrics and to better understand the correlation and the connection between different metrics. But the idea here is to keep in mind that it plays a key role in understanding the immediate role data can play within the business. And so in a more practical way, the idea here is to try to define the inputs and the outputs of the company using metrics and try to turn the company into a big formula that takes inputs, generates outputs, and then you can decide how to impact and how to influence those levers in the inputs to impact the outputs. So once you have that very high level alignment, once you have that very high level understanding in which you cover all the key areas of a business and all the key use cases for the data, you can start modeling. And the first type of model you want to tackle is the conceptual data model that will give you a very high level image and a big picture of all the key entities within the business, the relationships, and also the different data domains they fit within. So here the idea is that it needs to be high level. It needs to be business focused. You need to clarify the key entities. You need to ensure that you have alignment between all your stakeholders on these key entities, the relationships, and the overall scope of the data. What are the areas in which you want to leverage the data in the short term? This is a process that needs to be iterative. If you do it in just one go and say, okay, this is fine and I want to move forward with this, then probably there's something wrong with the process. It needs to be something that you update based on initial feedback. It needs to be something in which you involve as many stakeholders as possible. And the output needs to be something on which you have alignment and on which everyone agrees that, yeah, this makes sense for me. So a very basic example, something I am just to showcase like the expected output. You would have the different data domains, you would have the different connections between the domains, and then within every domain, you just need to define the key entities. You don't need to go into the details, you don't need to think about the attributes, the metrics, just the key entities and how they're connected to one another. The notion of domains may be a bit confusing here, in the sense that some entities live within a blurry area between two domains, for example. So it's not a rigid separation. Don't make like the separation between the different domains the key focus. The domains are the grouping, but it's fine for like an entity to be part of an area between two domains or owned by teams from two domains. You just need to focus on relationships, the key entities, and ensure that you don't miss a key part of a business when you finalize the conceptual model. Once we're at that level, the next step is to go into the details and think about the logical data model. Here, it's a matter of refining that conceptual model, adding more context, adding the attributes, adding the metrics, and adding the metadata. So you would dive into the attributes and metrics. You would do this exercise ideally at the domain level. So for every domain, you want to go and define the logical data model for that domain. This bounded context allows the right expertise to be involved, allows the right people to focus on their domain, and allows you to ensure that you can go into the details. You can ensure that all the metrics are covered and that the right people are focusing on the domain. You would do a lot of refinement also of the business requirements of what can be achieved and what can't be achieved. And you would also start looking to the left. So up to this point, we only look to the right. We only look to business use cases, business needs. Now you want to look to the left of your data platform and look at your data sources and say, okay, for these needs, do I actually have the data to serve the different use cases? For example, if it's product data, does your product team or product teams generate the sufficient data for you to go and calculate certain metric? If it's data you're getting from, you need to get from a SaaS system, are you currently getting that data? Do you need to pull it via an API? Do you need to store it somewhere? So it's a matter of just ensuring that you have the right inputs to deliver the outputs that are part of a logical model. And then you start enriching all of this with metadata, definitions, metrics, ownership of the data, a lot of things that enrich the model and ensure that you're covering all the key areas of the data product that you're building. So to give you a very brief example, if we go back to our initial data model, if we go to the logical layer, as you can see for the product domain, the idea here is to add some more entities that are not part of conceptual model, that are less critical to the overall picture. You add the attributes, you add the key metrics, and you expand the vision. Like basically, it's like zooming into the domain and adding as much context as possible. Once you do that three-step process, so you define all the key business use cases, all the business needs, you define a very high-level conceptual model, and then you define a domain-specific logical model, you'd be at a place where you can actually start building things and you can start building data assets that serve data products. However, there is one complexity that gets added to the mix that most of us need to deal with, which is you're no longer, as data team, you no longer do this type of exercise on your own in a corner. Instead, like the domain is owned by different teams. It can be satellite teams, like you have one analyst in team A, another analyst in team B, or it can be separate data engineering teams. But the idea is you have distributed ownership in terms of a domain, in terms of a model, and you have a multi-team environment that needs to collaborate on the ownership of the data model. My recommendation here is to have the conceptual model, again, at the company level. It needs to be universal. It needs to take into account all the domains, but the logical model can be at the domain level. And so here you need to avoid creating a monolithic and a very complex logical model that tries to fit into everything within the company. It's fine to have different teams own their own logical model for their domain. However, you need to ensure a certain level of governance. And so based on how you structure the different teams, based on the dynamic between the teams, two paths are both valid. You can either like enforce modeling methodology on all the domains. So you can say, we want all of our domains to be modeled using, for example, dimensional data modeling. Or if you're in an environment where the use cases differ quite a bit from one domain to another, you can say different teams get to make their modeling decisions within the domain. And it's fine for team A to do dimensional data modeling and then for team B to do one big table, for example. But the idea is to maintain a certain level of governance across the domains. And to just get the point across, governance, documentation, and building standardized interfaces between the different domains. So for every domain, you need to ensure that like the key assets or like the key definition of the logical model is standardized, and there's an interface that can be used for someone from team A to understand the reasoning behind a decision taken by team B, or how like the model for team B functions. We'll go into this with more details in the tools section. There's a specific tool that really works well here, but the idea is that you need to keep governance in mind as you go through the process. To end it up for this section, I want to talk about two particular attributes or two particular concepts you need to keep in mind. First one is that you need to embrace agility and iteration. Data products evolve, data products change quite a bit based on feedback, based on things that change in the business. The same needs to be true for the data model. And so, again, as you think about data products, the data model itself needs to be iterative, it needs to be adaptive, and it needs to be something that evolves with the data product and with the changes in the business. That means that when designing your data model, when making like design decisions, it's really critical to minimize the cost of future changes and evolution. It's very important that you minimize the number of one-step doors that you take. Don't take decisions that will be costly to reverse in the future, and try to maintain as much flexibility as possible. In practical terms, for example, this can mean keeping the lowest possible data granularity in the data whenever possible, ensuring that you have built-in flexibility. So let's say a part of your data model is going to be used for a key use case. That means the data will be queried using specific pattern, which requires certain efficiency, but will be slower for other query patterns. Those types of compromises can be risky in the sense that in the future, you have another use case that queries the data using a different pattern, and you find yourself stuck, or you find yourself in a place where you need to do a lot of costly changes to ensure that the data remains queryable via the two patterns, or that you minimize the cost. Whereas if you do the exercise from the start and you ensure that you still keep the door open for different query patterns, you minimize the risk of having to change things in the future. And then the last point, and probably one that usually gets overlooked, is avoiding what I would call the safe bet fallacy throughout the whole process. A safe bet fallacy for me means that you pick a methodology or you pick a process or technique simply because it's an industry standard. So you say, okay, everyone is doing this. That means it's the right approach to take. In most cases, yes. In some cases, it's not really the best approach. And you may be the exception. You may be that case in which it doesn't really make a lot of sense. So whenever you're making that type of decision, whenever you're saying, should I apply this methodology that's used widely across the whole industry, a good technique I would recommend is like trying to defend the counter argument, trying to say, no, and here's why it's not a good fit for me. Try to list all of the reasons that come to mind, and then go to the yes part and say, yeah, it makes sense, and here's why it makes sense. And then if you do end up with a decision that says, yeah, it makes sense, at least you ensure that you're not falling into this fallacy and you're not just adopting something because it's a standard, even though it may not be a good fit for your use case. Another thing to keep in mind here is that you shouldn't rush into decisions. Yeah, things change. A lot of back and forth needs to be expected, but at the same time, you need to ensure that when you make a decision, you capture all the key information that's available to you. That means once you talk to stakeholder number one and you get some feedback from them, before incorporating that and before saying, yeah, okay, this is the approach I want to take, you need to talk to other stakeholders. You need to get more information about the technology itself, about potential other use cases, about things that are happening in other organizations before you say, yeah, okay, this is what I want to do. And that ensures that you don't have any blind spots and that you don't move forward with the decision and then you realize that actually it would have been more efficient if you have done something different just based on a use case that you missed. Lastly, and probably most importantly, it's fine to change course. It's fine to start and then realize midway that actually it's not scalable, or actually it would be more efficient if we do things differently. And you say, let's reverse, let's change how we're doing it, and let's do the approach in a different way. The best time always to make that type of decision is right now. The more you delay it, the more you say, let's keep it for later, the more you say, let's push to production and then we'll figure it out, the more impactful and the more costly it's going to be to fix later on. So even if you started the process, even if you made some decisions, it's completely fine to change course, accept that, and design with that in mind for you and for your team. Ensure that it's always something that you keep in mind. So that was it for the practices and the processes. Now we move to the fun section in which we talk about the tools, the frameworks, and the technology. All right, so now that we covered processes, let's go into the fun part and talk about the tools and frameworks that you can leverage throughout the whole process and even after your data models get to production. So the first thing I want to talk about, and it connects back to the first section of presentation, is metric trees. So we talked about figuring out the key metrics you want to focus on and defining how they connect to the business and defining how you want to calculate them at a high level. Metric trees are a very nice concept that allows you to do that in a very pragmatic and in an organized manner. It's not an exercise that the data team does on its own. It's an exercise that you do at the company level or at the level of a specific org, but it's very useful and it's very practical to define the metrics in an efficient manner. So a metric tree is basically just an organizational chart for the companies or the orgs, KPIs and metrics. You usually start with a North Star output metric and you break it down into component metrics. And then for each of those component metrics, you also break it down into other metrics until reach a point where it's levers that you can influence and it's no longer metrics that you can break into more like manageable metrics. For every metric, you have multiple ways you can decompose it. That's completely fine. It's up to you, like to choose the decomposition that suits the levers you want to pull or how like you want to focus, like the things you want to focus on within your business. And to show a very like simple example, you start with something like the total revenue, which would be the number of orders multiplied by the average order value. Then you would look at the number of orders. You would say this is the website traffic multiplied by the conversion rate. And for the average order value, it's the average items, the number of like average number of items per order multiplied by the average item price. You can, again, decompose these metrics more until reach a point where it's something you can influence. And then throughout that process, usually the formulas can be things that you calculate in a straightforward manner. So it's metric A multiplied by metric B. Sometimes it's less straightforward, but it's fine. The idea is just to identify the key metrics and how they connected to one another. Another key concept or tool that's really useful to better define, like better govern and define the metrics. Once you do the metrics tree, once you have alignment between all the stakeholders or all the key stakeholders for that area on the metrics, how they're connected to one another, and the definition of the different metrics, you want to ensure that it's stored in a governed manner, in a centralized place, and that you have a process around the definition and the change of that definition for every metric. Semantic layer, it's a concept that has been a very hot topic in the data space for the last maybe 5 years. This year, it's yet more, it's becoming more and more common. A lot of tools within the data space offer specific capabilities for it. Very famously, dbt has its own semantic layer, but there are other tools that provide similar capabilities. And the idea is, again, to connect those business metrics to actual data assets. So you'd bring the definition of the metrics and you connect it to tables and assets within your data platform. It allows you to do it as code and in a centralized manner. So it adds the whole governance layer, and it also adds a layer of standardizing the definitions and ensuring that everyone is consuming the same definition of a given metric. Usually it's in a very accessible format. For example, dbt does it in YAML. It's easy for a wide range of personas and a wide range of users to interact with it, to understand how a metric is generated, to understand the different ways a metric can be filtered, for example, and so on. And so usually it's a good place to ensure agreement and to ensure that everyone has the same understanding of a metric. Another interesting criteria or another interesting feature of the semantic layer is that it abstracts how queries are constructed. It opens the door for cost reduction, performance optimization, since it's usually an engine that's doing all the querying of a warehouse. It knows how to optimize those queries. It can do a lot of things like doing, for example, optimizations in terms of how the queries are created, or opening the door for things like doing caching, for example, to ensure queries are the results of the queries are stored when they're run multiple times. A very high level example here is semantic layer. On the right, you have the different ways you consume the data or the metrics. It can be your business intelligence tool. It can be a data app. It can be, for example, a notebook in which someone is experimenting. It can be a reverse ETL tool. They all have the same definition of a metric, but that's defined in the semantic layer. And then that semantic layer interacts with your data platform or your data warehouse. It sends the queries and it gets the data in response. A very simple example here from the dbt semantic layer of a definition of a metric. You see that it's very accessible, it's easy to define, it's easy to understand for a wide range of users, even if they're not familiar with like SQL or with coding languages. At the same time, it allows for a very high level of governance, both in terms of the metadata you provide. So a description, you can provide an owner, you can provide some context about the metric. At the same time, you provide the key levers and the key characteristics of the metric itself. Now let's go into modeling the data within the platform itself. So in the first section, we talked about data modeling at more of a high level, at a high level. And now we're talking about data modeling in the platform itself. So we're getting much closer to the physical data modeling, which takes into account the platform and the technology we're using. I would still recommend looking into the classical methodologies or like the methodologies that became the norm in the 90s. Again, we go back to dimensional data modeling. It's still something that's very useful. It still makes sense in a lot of cases, but you do need to adapt it to the modern tooling. You do need to adapt it to a world in which storage is very cheap, compute is very scalable, and the use cases are very different from the use cases of the 90s. Another key methodology that personally a big fan of and that I think makes a lot of sense is an entity-centric modeling, in which the focus becomes on the dimension tables. So you go back to dimensional data modeling. Instead of having one fact table and a lot of dimensions with which you join, you have one big dimension table that's very wide. It contains a lot of metrics, and then it's joined with a number of fact tables or a number of tables from which you get the metrics. The reasoning here is that, and you probably noticed this when we did the first part of the exercise, the focus is on the entities. And today, a lot of the use cases focus on one entities and the large number of metrics for that given entity. And so it makes sense to have a dimension table for the entity with all of the metrics that make sense for it. It makes sense to make the entity the central piece of the model instead of the fact being the central piece or the fact table being the central piece where you store all the metrics. And then the last point I want to mention is that you do want to optimize for the quirks of your platform. Here, for example, if we look into partitioning, it's different from BigQuery compared to Snowflake. Different data platforms handle data types differently. So for example, for semi-structured data, it's a good idea in some places. It's a bad idea or not as good of an idea for other platforms. So here, you need to take into account your own platform and what's most suitable for your own use case. And one very tiny last point I want to mention is ensuring that as we navigate things horizontally, so all of the modeling we've been talking about, it's done at one horizontal layer of the platform. You also need to keep in mind the vertical layers, which are your data pipelines and how data moves from one layer to the next one. So you have your raw data, you have a lot of intermediate steps, and then you have a consumption layer or a place where the data is ready for consumption. And the data modeling needs to be adapted to the layer in which you're operating. So to give you a very basic example of what I was talking about in terms of like entity-centric modeling, this is what it would look like. You would have a wide dimension table that's connected to a few fact tables. And instead of a fact table being the center of your data model, the dimension table becomes the center of the data model because most of the use cases would rely on one entity and different facts or different metrics and measures that are connected to it. The last piece of tooling or the last artifact that I want to go through is the design doc. This is something that's very common in the software engineering space. It's unfortunately not as common in the data space. And I think that's a big problem and one of the reasons in which we have a lot of governance and ownership issues. Um, at a very high level, the idea here is to have one document for every data domain or for every data product in which you list all the key metadata, who are the owners, who are the reviewers, who are the people who need to be involved in terms of decision making, what are the key decisions that you have took for this particular data pipeline or for this particular data pipeline or data model, basically all the component of a data product. You want to look at the main inputs, what are the different data sets that we're going to be consuming, and the main outputs, what are the different outputs and artifacts that are being generated as part of this data product, what are the key metrics that we're calculating, and what are the key use cases that we're serving. So just documenting all of this in one place. And then you want to go one level more granular and document things for every asset. So for every table, you want to say, okay, what are the attributes that are part of this data product? What's their definition? And then for the asset itself, does it have any freshness or data quality guarantees? Are there any tests we need to be running? What's the commitment in terms of like the refresh frequency? How fresh does the data need to be? What's the estimated cost, which is a big component, like a big factor in terms of the design of the data model itself. Ideally, this is something that goes through a review cycle. You ensure alignment between the different teams, and before like you start building or you start creating assets, this would be something that needs to be approved and that would need to be stored in a central repository where you have access to all of the different artifacts or all the design docs. This also becomes the interface that we talked about initially between the different domains. So if I'm someone who's working on data product A and I need to understand certain design decisions for data product E from which from which I'm going to consume a table or an asset, going to the data, to the design doc and looking through the reasoning and looking through the different decisions would give me the right context and would give me the right information to consume the data in a way that makes sense. And the last point here is that, like everything else we discussed, it's something that evolves. Don't expect it to be static. It's not something that you do once and you forget about. So as the data product evolves, as you add new use cases, as like the usage changes, the design doc would be updated to reflect the current image of things. And the design doc would contain the reasoning for why certain things were changed or how a new use case or new usage pattern impacted a decision in the design. And in like just to add more clarity around it, this is something that you can do at the data product level, or if in your use case it makes more sense to do it at the data domain level, that's also fine. Now that we've covered everything about tooling, so again, metric trees, the semantic layer, adapting the data modeling to your own data platform, and writing design docs, let's go to the conclusion. Let's try to summarize all the key topics we went through in the two main sections and try to see what are the key things you can apply after the session in your own data platform. All right, so to sum things up for the conclusion, first thing, data products are here to stay. It's something that, again, like if you go back to the timeline and why we get to an environment in which there is a big push towards data products, you'll see the value around thinking of data this way and thinking of data in a matter of like, okay, what's the value that it generates and how can we measure that value? So you should definitely expect that this would be the environment in which most data teams would operate in the future. And so having robust processes and having a lot of thinking around how to tackle data products and how to design data platforms and data models that are well suited for them is a must. Then when you go into those type of processes, into those types of workflows in which you're designing your data model or data platform for data products, iteration and alignment become much more critical because, again, data products evolve, whether during the development, whether after they get to production, and your processes need to be aligned with that type of iterative approach where you need agility and you also need alignment between the different teams that are involved. To make matters easier and to make it much more efficient for you and for like the different stakeholders to connect the data to the business, it's very useful to define the business itself through metrics. Here we went through like metric trees, but also the process by which different orgs and the different stakeholders need to align on the definition of metrics, which you can then get into code via the semantic layer, and which you can then standardize and turn into a production-ready data model via semantic layer and the different tools in it. In terms of modeling techniques, we talked about quite a few at different levels, whether it's the conceptual, the logical, or the technical model. You have different tools and different ways for which you can adapt either existing techniques or introduce new concepts to perform the modeling. Again, it will depend on your technology. It will depend on the use cases you're tackling. There is no one size fits all here, and it's a matter of understanding the use cases, understanding the needs, and then choosing the best fit for your scenario. And finally, again, this is something that I discussed quite a few times in the discussion. It's very important to document. It's very important to ensure and enforce governance. It's the only way this all scales, and it's something that you need to get focused on since first day. You need to have processes for it, and you need to enforce it in an automated manner. With that in mind, I think we covered everything we had for the session. Thank you a lot for the time. Thank you for going through all these topics with me. I want to also thank again the Modern Data Company team for the invite. If you have any questions, if something wasn't clear, if you want to go into the details of something specific, feel free to reach out. I'm available on LinkedIn. I'm available on Blue Sky, also on X. So yeah, I guess we covered all the main points we wanted to go through today. Thank you for your time and take care. Bye.
Access the Modern Data Masterclass for free on moderndata101.com/masterclass.